southern breeze, strange fruit hanging from the poplar trees. Pastoral scene of the gallant South, the bulging eyes and the twisted mouth, scent of magnolia, sweet and fresh. Then the sudden smell of burning flesh. Here is a fruit for the crows to pluck, for the rain to gather, for the wind to suck, for the sun to rise, for the tree to drop.
talk to me this way, right? If you ask questions, I ask you to please go ahead and use our radio mic, because that way, if somebody's listening at home, they can actually hear the question without us repeating the questions. So that's handy. Yeah, good, okay. Is this on? Yeah, okay. And you can hear me way in back over there? Yeah, good, okay, good. Yeah, we have a lot of fun at the course, and as you can probably see from the pictures, and so part of this is, it's a lot of work. You're gonna do a lot of work while you're here. And nevertheless, we wanna make sure that you enjoy yourself while you're here, because that's, I think that's probably an aid to learning, and it's my theory. It's a good theory. It's my theory. So let me just go ahead and start. My name is Mark Cohen. We've been running this course now. This is our 9th year. The Neuroimaging training program itself has been going on for 9 years. We have federal funding for the program. And the program itself was funded by the NIH back in 2006. Just interestingly, we actually lobbied for funding for this thing for a good 5 years before we were able to get this. So starting maybe 15 years ago is the history of this course, where it was clear that this business of neuroimaging was growing really rapidly, and yet it's a ridiculously technical field. And so it was clear that it was necessary to find some way to teach people how to do this stuff. We helped the NIH with the process of developing the RFA for funding this thing. And the idea really behind the neuroimaging training program is to try and bring in a higher level of technical expertise into the field. And so the NIH actually saw it as an interest on their part to try and train people who come from outside what might be traditional neuroscience disciplines. So, you know, people in statistics and engineering and math and physics and, well, you know, by now, like half of you guys, that's your field, right? You came in from there. But that's not how it started. This started with a bunch of people who were neuroscientists and psychologists who were trying to use this, you know, state-of-the-art crazy equipment and make sense out of it. And we decided, even when we applied for the program, which was back in I think 05 or something, that we would try and produce an advanced program with the understanding that people were already by then using these tools and started getting to know them. And we saw an opportunity to try and take people to the next level. So the people who come here are all people who have experience, significant, substantial experience. I'll kind of go through that with you, and you'll learn from each other about who you are. And so we feel like the point of this course is to try and really stretch where you are with this. As I say, we've been funded since 2006. The neuroimaging training program here at UCLA has 2 components. One is the one you're participating in, which is the summer course. The summer course, we have a very generous award from the NIH, $100,000 a year, which is spent running this summer course. And that allows us to do some of the lavish things that you already know about, like, you know, paying for your housing and giving you nice deluxe places here to work. It also allows us to bring in anybody we want as speakers on here, because we can afford to fly in people from all over the world, and we have. It's probably now a list of 50, 60 people who have been here as guest speakers. They come from all over the world. And what we try to do with our guest speakers is bring in people who, number one, are great instructors. Number 2 are people who are answerable for the stuff that they're speaking about, in the sense that they're either leading proponents or the principal developers of these things. So folks who really are the best in the world at each of these topics. So when you ask people questions, they will hopefully be able to give you definitive answers, which is certainly half of the fun with this. We have, in addition to the summer program, a graduate fellowship program. About 5 people in the room here are part of our graduate fellowship program here. And that allows us to give 1 year of funding to students here to give them a very, very immersive course in neuroimaging. And that's right now we teach that as a 2-quarter course, which involves a ton of math, a ton of physics, a lot of neuroscience, a lot of fun discussion. I mean, I'm sort of looking at the faces of the students in the room who've been there with this. But just to sort of get some taste of that, we actually sit down and build devices in the classroom. We built, I think, an EEG system last year. Is that what we did? Yeah. So people learn about transistors and op amps and filters and these kinds of things, because we really feel like this is an opportunity for people to define what the next generation of neuroimaging is going to look like, and we want people to totally be able to know how to use their hands with that. For the summer course now, it says approximately 300 students have been trained. It's actually closer to 350 right now that have run through this course. And this course, we bring in really good people. They all end up doing really good things. We track what kind of successes people have had here. And, I'm not sure that the course gave them their success, because we were so selective about getting people in here that most of you people are guaranteed to go on to great careers. And sort of what we're trying to do is help that along. Okay. These things are still not up to date with my numbers. About 300 summer students. I don't know why that list is so short. I'm sorry, this list of countries is totally wrong. There's about a dozen countries that have been participating right now. And one of the really nice things about this particular NIH award is that it does allow us to support non-US students. And that's an exceptional thing. In fact, we also have fellowship slots here at UCLA for non-US students, which is just way outside of what NIH ordinarily does for training grants. So just to tell you a little bit about who you are in this room, this year we had 131 applicants, 31 countries, 93 institutions for people applying for the slots that you are in right now. To put that in perspective, the 1,746 pages of applications that we went through in order to select the people that are here. I have an incredibly dedicated committee of people who have made this course happen. You'll meet all of them. Every single application that was in here got 3 to 5 reads. We ranked them and scored them. We then went through those people who were in the top roughly 25% and discussed them individually to make sure that we were really sure we're getting people who were strong here. It's always been our priority to bring in people who we think are in a position to help other people. So when we look at the applications, we look at evidence that you've been interacting with your lab, that your PI thinks that you're bringing in important stuff to the lab and you're likely to be disseminators of this content. By the end of this year, in this audience, you've each written an average of 3.5 first author papers, 7 co-author papers, 12 abstracts in the field. So that's pretty good. Last year, we actually, it was getting up to 7 first author papers, but that's because we had 2 or 3 people who were department chairs in the audience who had written 116 papers by the time they were through here. So we have a slightly younger crowd this year, which is great. Still coming in. Welcome, welcome. Pick up name tags. There seems to be an accumulation of luggage in the back. Okay. This course is, in fact, broadcast live. That's something we've been doing for 7 years now, is running the webcasts. To get you some sense of the webcasts, we reach 200 countries in a typical year. We have several thousand viewers for the webcast. We know that that people actually schedule their lab meetings around viewing the webcasts. I've had a couple institutions tell me that they every week have been running one of the lectures, you know, just for as part of their lab meetings, and I think it becomes a valuable resource. We of course archive these things so that they're viewable. How many people in the room have actually seen the webcast? Yeah, that's good. About half, it looks like, have seen it. Some of the same slides will appear this year, but we actually do keep things pretty fresh. Okay. And for those, well, I guess anybody in the audience who's looking at the webcast knows the URL for the webcast, so I don't really have to tell you that. So what I want to do next is talk you through a little bit the schedule that we have this year. Is there anybody here who doesn't know how to find the course schedule by now? Yeah, okay, I'm sure you all do. For the audience who might be listening at home, it's www.brainmapping.org/N, T, and you'll find a link on there for the summer 2015 course, and you'll pick up this portion of the schedule. So 2 weeks of fairly intense work. One thing you should know about the schedule is it's actually a dynamically created web page. We change the contents constantly for this. And one of the things that we do is post the speaker's slides as they are there. So 90% of the time we have the slides for the speakers before the speaker is actually up here speaking. But not 100%, because not everybody is quite, you know, like some speakers come in and they just want, you know, you guys to see whatever they did that morning, and so they don't get it into the slides quite that quick. And, you know, we welcome that, but we try and make it happen. There are links on the page for feedback. And unfortunately, I don't think this one is live yet today. My computer support person stayed up until 2 in the morning trying to make some of the course contents for here. And so we probably will get the feedback link done by the afternoon. But we're very eager to have audience feedback for this. We use this really heavily. As I say, we've had maybe 50, 60 speakers from around the world speaking here, and some of them get invited back. The ones who get invited back have received great ratings from the people in the audience, and the ones who haven't might be incredible scientists, but if they're not really great speakers, we don't want to hear about them anymore. So, you know, we're a little brutal that way. We've had people call up and ask to speak second times, which has been embarrassing, but oh well. Okay, so course content in there. So in addition, you'll also see that there are various panels in here which are labeled in darker gray, and those represent lab experiences. And the lab experiences are a chance for you to get your hands on with the software that is used in people's analyses, principally that. And the most of our speakers, even our outside speakers, are providing this software. Much of it is brand new. And this afternoon, we'll have a little lab dedicated to getting that stuff installed on your computer. We did actually list most of the software that we're using already, which was downloadable from the FAQ, but I think that you'll find this useful. We'll be giving you little flash drives that have the software on it, and they install a whole work environment for you as long as you're running some kind of a recent computer, 90% of which are Macs. That's so funny. It's a whole commentary on here, too. Okay, so much of the course is set up in lecture format. And so the lighter gray things are basically just classroom lectures like this. We have an extraordinary bunch of speakers. And then we also go ahead and start doing the labs. The labs are called out here. And you can see that, that each week we have half a dozen labs. And they tend to be a whole lot of fun. We'll be here with staff to go and help you out with the labs and walk around and show you things as you go. And then another feature of the course are our group projects. The group projects it's kind of actually been a somewhat contentious thing about the group projects historically. We had a couple of years where we didn't do them at all because there was a theory that by one of the instructors here specifically who said, look, we don't want people to get the idea that you sit down for a couple of hours, run an hour worth of experiments and publish something in Science, right? Obviously doing real fMRI works, real neuroimaging work requires very considerable amount of thought. And yet, on the other hand, what we found was that the group projects were a way for you guys to get to know each other, which turned out to be very important. I did some tracking of prior attendees in the course about 4 years ago when we applied for a renewal for the federal grant for this, and I found that something on the order of 30% of the people in this course ended up collaborating on manuscripts and scientific research with other people in the course. And I'm quite sure that that's a consequence of you having built the interaction with each other in the group projects, because you'll find that you're among scientists who are very strong. You'll also find, if you don't already know, that doing anything serious in this field requires expertise beyond your own, right? You need, if you're a neuroscientist, it's very handy to have a physicist around, and if you're a electrical engineer, it's very handy to have a computer scientist around when you do these kinds of things. And so the sort of networking portion of this, I think, is really, really important. I'll talk with you a little bit more about how we're running the group projects this year in a moment. It's also important to get to know each other socially, and so we have always had some sort of a social event as part of this thing, and the first thing we ended up realizing is that we want to move that really early into the course, and so our first social event is going to happen tomorrow night at Barney's Beanery, good famous Los Angeles institution, where we have taken over the first floor of the Barney's Beanery, second floor of the Barney's Beanery for our karaoke party. Our karaoke parties are always really, really, really fun. For those of you who were watching the slides, but while we came in, they tend to be crazy, and that's good. And you tend to get to know each other, and that's good. And this year, rather than having just a single social event, we've decided to do two. So in addition to the sort of getting to know each other mixer thing that we're going to do tomorrow night, we also have a gala dinner, and we'll serve you a really nice meal, and that should be fun. And let's see, what else have we got? Next week schedule. We have one more social event, which is our photo day. You really want your pictures in this collection of I really want your pictures in this collection of trophies that I have for the course. I actually have them posted outside the wall in the hallway, like big poster thing, because this to me is a matter of huge pride, having all of you here, and hopefully to you as well. So going on to kind of next week, it does get to be a tiring process. It just, like, you're going to be working hard. We really try to break things up. The lab things are a little bit of a refresher from sitting in the classroom watching slides, and there are a lot of them next week. Then we continue on with more time to work on the group projects until on the final day of the course, we actually dedicate basically the whole day to presentations of the group projects. We've seen it all as far as the presentation goes. Last year, there was one group who managed to do a rap. And they got, 15, 20 people in the room to go and participate in doing their project as a rap. Other people actually go ahead and give us scientific presentations on PowerPoint, which are good too. No judgment here, and please don't feel that you need to dress in funny hats in order to give your presentations, but we welcome it if you do. Okay. And actually, I'm going to go through just back a little bit more on the actual lecture stuff and see how we've organized that. So we follow a progression here from sort of fundamentals of the neural systems and then of the technology of the imaging systems. And we follow that up by the sort of general and basic analysis, data analysis strategies from here. For some people here, I guarantee you that some of these things are going to be, review. And for some people here, they're not going to be. And I ask you to sort of indulge that, maybe you've seen it before for some of these things, but I want to make sure that we get everybody on the same page with this. In particular, I think that hopefully many of you people will have seen 95% of what I have to say in this first lecture on basically how neurons work. But we do it from the perspective of trying to get you to understand how that couples to these other issues, like how you do MR physics. By the time we're into Thursday, we're already pretty deep into advanced concepts from here. So when we talk about non-parametric statistics, we're sort of already off the deep end compared to what's mostly goes on in conventional MRI. Dynamic causal modeling. This year, we are very fortunate to be able to do a very sophisticated thing on multivoxel pattern analysis and machine learning because we just managed to get the best people in the field to come here and talk about it. So Jim Haxby's going to come and present that stuff, as well as he has been arranging with Dr. Pamela Douglas here to go ahead and do a laboratory exercise using the most recent tools from their outfit. We also are doing causal modeling with Randy McIntosh, and we'll have a laboratory for that. And then as we move towards the end of the week, I'll be giving you a talk on magnetic resonance imaging safety. And I do this for two reasons. One is because I think it's an underlearned skill. I think that I worry all the time that we're going to shut down this entire field of functional neuroimaging because a psychologist is going to go in and do an experiment and kill somebody. And you laugh, right? I'll show you why this is a serious thing. It's really, really super important. The second reason I do it is because as part of our group projects, we actually do encourage you to go ahead and run experiments in our lab. And I really don't want you to screw it up in our lab. So we'll get that stuff right. By the second week, we're moving on to pretty high-level analysis, and so you're going to see a few things in the second week that hopefully are brand new to you. For example, how many people here have used FNIRS yet? Functional near or infrared spectroscopy. Oh, okay, good. So you'll go ahead and hear some interesting things. How about compressive sensing? Anybody know about that stuff yet? Good, all right, good news. So these are kind of fun things. Okay, moving on to my animated slides. So as far as is this interesting? Yeah, okay, good. So as far as the group projects go, we have had, I would say 80% of the people who send us our reviews say the group projects were really great, right? Really great experience. And then something on the order of 20% have given us kind of negative reviews about the group projects, feeling that it didn't necessarily work out for them well. So this year we've decided to change things around a bit and suggest that your groups might either engage in research experiments using our equipment and all the various resources that we have over here, or you might go ahead and try and work out something that's more an intellectual exercise, which is a debate format. And I'm pretty excited about the idea of the debate format here because I think that'll be a fun and useful thing. And frankly, whatever issues you decide to bring up as interesting debate topics, I will then go and send back to my program officers at NIH and talk with them about what people think are important topics to be doing work on, and these are also potential opportunities for funding. And so the NIH is, in fact, very, very interested in trying to hear from people who are young scientists and who are trying to define the new state of the art. So this is not just a totally academic exercise. We've had some ideas about group projects that I think are interesting as challenges. And I don't think I want to talk through all of these right now, even though I wrote down a lot of them. But there are some general topics in functional imaging that I think are very poorly explored or understood. For example, what does neural inhibition have to do with the Bold effect? And can you try and think about maybe experiments that will address that in an interesting way? Functional localizers are a really big deal. People know about that, you want to be able to identify various brain regions in a quick way so that you can go ahead and do targeted experiments in there. I think a really interesting and hot topic is the relationship between the fiber tracts that we pick up with diffusion tensor imaging, which you're going to hear a fair amount about, and the actual functional connectivity of the brain, because in fact these things seem to be loosely linked. And so trying to understand how these are bound might be a fun series of experiments. The group projects would be kind of a choice. You're going to design, run, and analyze data, or you're going to organize and run a debate. And we actually sat down with the committee, which were, I think, 6 or 8 people in the committee, to try and come up with debate topics that we thought were worthy of your attention. I would ask, when you do these debates, for those of you who decide to self-assign to that, that you take these kinds of general questions and form them in a typical debate context. Either give us an interpretation like MRI is irrelevant in cognitive psychology, yes or no. We would ask that you divide yourselves into groups to argue both sides of this. It's possible that we could end up with 2 different groups who are arguing 2 different sides of the thing. It's a little ill-formed how we're going to do this, so we're going to spend some time thinking through exactly how we want to run those debates. I'm going to skip those because you've seen them. I'm going to skip these because I've spent enough time on this already. For those of you who decide to go ahead and run experiments in the lab, we actually have a pretty sophisticated set of tools around here at UCLA, possibly better than you guys have at home. I say possibly better because we started off really early with the Siemens Trio. We were one of the first sites around to have this thing, and now it's getting old and we're getting our replacement one in, which will be the new Siemens Prisma system. So some of you guys may have leapfrogged over us, but that's okay, we'll catch up, we'll kill you. So we have a great system out there. It's set up with a very sophisticated set of audio video tools in there, so that you can bring stimuli in and out to the subject. We have lots of response pads, keypad things. One of the things we have here at UCLA, which is rare, although not unique, is the possibility to do concurrent EEG and MRI. And several times in the past, people have decided they wanted to experience that as part of their group projects. We've had projects, for example, in sleep, where people use the EEG MRI combination, other stuff with looking at continuous wave EEG and trying to link that to what goes on in the MRI. We have cardiac and respiratory tracking. We have a really good selection of extra pulse sequences here, including arterial spin labeling and the multi-band, multi-slice interleaved sequences. People know about, how many people have used multi-band sequences? How many people have no idea what I'm talking about? Okay, all right, so most of you haven't experienced it yet, but know, and those are fun. That's really fun. And then we also, if you feel like you need to do it, we also have apparatus to do more exotic things like olfactory stimuli, electrical shocks, and so on for there, because people use that in the lab. In addition, we have a lot of online, archived data. And I don't really encourage people to sit down and do a bunch of high-resolution DTI scans because, in fact, there's very little reason that we need to recollect that data unless for some reason you think that something you're going to do in this week is going to change the structural connectivity of the subjects you're studying. Or if you particularly need to try and constrain your data by the DTI connectivity. But even so, we have a lot of available online data which has both the structural and resting state images for there. And we also have the entire Human Connectome Project archived data here. For those of you who choose to use it, we will very quickly get you into the system so that you have access for that, and we have good computing resources for doing that. It's time to do just a teeny weeny bit of introduction over here. To starting off with the people who are the course directors and organizers for this. In particular, I want to point out Agatha Lenardowicz, who's sitting in the back over there smiling, and Susan Buchheimer, who is also in the back over there smiling. Jesse and Martin will be showing up today. Jesse Rissman and Martin Monti, who have been course organizers with us almost since the beginning, not quite since the beginning, because Martin, who is in fact a faculty member here, was also a student in the second year of running this course. And we liked him and kept him, which is sort of fun. Melina Beatrice, who you probably have not yet met, but I would say you've all interacted with. Melina is absolutely crucial to not only this course, but to my life. She lives and breathes energy into the laboratory, and Melina is the one who's answerable for all of the administrative stuff that's made it possible for you guys to come here. I believe she also, we don't have it here for some reason at the moment, I believe she's also produced a entertainment package for the things that you want to do in the Westwood areas, where people have their happy hours and win, and stuff that's very important with that. And then in support rows also, we have Andrew Cho, who is going to be taking care of all of your computer needs, including developing all of this nice, cool software installation thing here. And June Dizon, who is Melina's assistant, and June has been responsible for an enormous amount of getting the name tags and arrangements and hotels and all these other things in there. As far as faculty go, as I say, we've had on the order of 50, 60 speakers here, and we invite some of them back. I think we've got a dozen of the speakers from more than a dozen of speakers from prior years who are here because we've just been so excited about the content of their courses, of their coursework. Vince Calhoun, who is part of our external advisory committee, Dan Ennis, who are UCLA Radiology, Steve Grant, who is actually the program officer at the NIH who made this thing happen. One of the most popular things we've got in this course is that on the last day, Steve Grant helps us out with a career panel where you get a chance to talk with the NIH funding officers and try and understand what it is that they see as the future of this course. Agatha, I introduced you to. This is Martin Lindquist, who's been here, I think, for 6 times teaching statistics. Randy McIntosh, who was here last year. Leo Moore, who will be teaching you ICA denoising. Martin, you met. Jesse, you met. David Shattuck, who does very advanced work with visualization software and analysis software. Avi Snyder, who will be talking about resting state MRI. Tali Arconi, who is a genius at using what was now what was then social media now into sort of big data meta-analyses. He's really a lot of fun. Van Wedeen, here teaching you something about spin physics or something with his hands. Van has also been a regular here. And we'll also be showing you his very cool TrackViz software for this. And then, of course, other people you met. Group presentations. And I think that's all I want to say here myself. Because I want to leave time for you guys to introduce yourselves. But if there are any questions for me, let me get the mic out. This is live now. So any questions? Things you want to know? Yeah, please. Here. I can't toss it.
When will we find out which group that we're in and when we're scanning on Saturday and Sunday?
So we will, do you want to speak to that, Susan? This is Susan Buchheimer.
Thanks. What we'll do is we'll have each of you come to me when you have a chance, but not until after I get a complete list of everybody's names. And after you've had a chance to think about what you'd like to do, you'll just say what you want to do, what kind of thing that you want to do. And then I will look over everybody, try to find groups of common interest, and then put you in groups then. So basically, you will do what you want to do. So if 5 of you want to do a debate on a certain topic, then we'll put you together in a group. So the group is still dynamic right now, and you can change if you change your mind. Okay, but we're going to try to keep each group to about 5-6 people. Okay, and you might have also figured by looking at the group presentations that the group presentations are not necessarily serious. They have been done, for example, in rap or things like that. Okay, so just FYI.
Sing-alongs, we've had
Yeah,
sing-alongs.
a lot of sing-alongs. Yeah. Okay.
But we've also had some very tight, good scientific standard presentations for that. Yeah, in a better world, by the way, I would have been surveying all you people for this stuff over the weekend with this. Unfortunately, my ceiling is coming down from a flood, and it sort of consumed me at the moment. Any other questions? Okay, Susan, would you hand the microphone to just somebody, for example, in the back row, and Katie, I guess, and if